Okay, good afternoon, everyone. Thank you so much for coming in. It really is a pleasure to have you all here. Um, and it's a decent crowd here as well, so really appreciate you guys coming in. Just to have an introduction, first of all, hey, I'm Fez, Physicals, so that's the name that I go by on the internet. That's the name that people sort of know me by. My real name is Burhan, and I'm from Pakistan, so just to give you guys some context. I am also like the head of marketing for Chutes, and that is what I'm going to be telling you guys about today as well. What is Chutes, why we created Chutes, and what is like the problem that Chutes is solving, and how again you can essentially use Chutes in your own workflows in your day-to-day, in trying to use AI and how you can rather efficiently and more securely use AI. So just to get an understanding of where you guys are at right now, I want you guys to do a show of hands. So how many of you here use open source models on a day-to-day basis? Like have ever used any open source models like DeepSeek, Kimi K2.6, GLM, any of the open source models? Okay, wait, let's move on. I see. And how many of you guys here have used ChatGPT or Anthropic or Claude or one of the closed source one like Grok or Gemini and stuff? Come on, like everyone should be using at least ChatGPT. You guys should be using. I expect all of you to be around. Okay, perfect. I'm assuming at least every in check so that you guys don't sleep in between. So the quizzes again, it's going to be exactly what I'm going to be saying. So just be attentive. So in there, there's going to be questions, and whoever answers those questions right, they get a shirt. So you see the shirt that I'm wearing right now. It's a pretty cool shirt. But yeah, you guys get the shirt for that. So just to get right into it, there's going to be three things that we're essentially going to be covering in this session. So the first one is why centralized AI is structurally broken. And by centralized AI, I mean the closed source models, which is essentially like OpenAI, Claude, like Anthropic, all of the Anthropic models, Grok, etc. Why it is structurally broken. And the second thing is where the world is actually going. So when we talk about AI, where the world is actually heading, and what can we expect in the next couple of years. And the third is, obviously, we're going to talk about Chutes, why we build Chutes, what is Chutes, and what you can essentially do with it, and what are the features, etc. it offers. So the first thing that you can essentially see here is the fact that the centralized AI economy is structurally broken. Why is that so? Okay, so you can see this big number, $725 billion. This is the spend essentially that the big AI, closed source AI labs did in the last 1 year in infrastructure costs alone. So this is their capex from 5 companies in just 1 year, which is, just to give you guys some perspective, this is bigger than Switzerland's GDP. This is roughly NATO's non-US defense budget. And to top it all off, like the cherry on the top, like on this spend, their AI revenue is a fraction of this. Like Microsoft AI, their revenue is like 37 billion. Google Cloud is also very similar to this. And their spending is almost like 2x on the AI revenue on CapEx. Like they're spending 2x more than what they're actually making. So it's like a very loss-making industry overall, which is not sustainable at all. So it's like a bubble that is essentially being created where money is being poured into AI just for the sake of it. There's like a lot of venture capital money flowing into these closed source AI labs, and they're not making any money at all. So even when you're actually paying for these subscriptions, they're not actually making money. Like they're barely making it through. Like you're just seeing like OpenAI like reported like record losses. So this is like the largest concentrated infra cycle in tech history, where it's just a bubble that just keeps growing, keeps and keeps on growing. Slide. Okay, so these are the five companies, and this is their spend. So Amazon leads by 200 billion, Microsoft leads by 190 billion, Alphabet has 185 billion, Meta is spending 145 billion, and the rest of the AI labs at OpenAI, Anthropic, etc., they go past like 800 billion globally. And this is the cost of playing the centralized game now. The cost of running AI in today's day and age. This is the cost of like the AI that you use on a daily basis. This is essentially what it has come down to. So investors are asking if this ever pays back. And you can just see this is OpenAI. This is the leader, which is like the benchmark. Like everyone is using OpenAI nowadays. Everyone uses ChatGPT. Like most of you guys would probably have the ChatGPT subscription as well. But they reported $14 billion in losses just this year alone. And just to put it into perspective, like ChatGPT is a market leader. They have like around 900 million weekly users and around like $20 billion in annualized revenue. And it's the fastest software company to that mark ever. However, like just to put that into perspective, they don't make that much money, and it's just they're projected to lose 14 billion in 2026 alone. And their cumulative loss through 2028, which is projected, is 44 billion plus dollars, and they'll probably break even like around 2029. That's still like a very very optimistic number. And for the users, 94.5% pay nothing, and OpenAI is to compute on every free query. Like you guys, yeah, usually accessible. Like ChatGPT has a free tier as well, but that comes at a cost, and 94% of the users they don't pay at all. So it's just a loop. They raise more to keep the spend going on. They raise more, they spend more, and it's just a bigger hole that keeps on getting bigger and bigger and bigger. So if the leader loses, like this is just a question to all of you, if the leader loses $14 billion per year, what does that say about the market structure? It's like very, very clearly it's a bubble that's just growing and growing and growing. And the next one. Yeah. So again, it's like they burn $2 for every $1 earned. And this is just on the inference alone, by the way. So when I say inference, that means the GPUs that they use, like the infrastructure, that is like all the data centers essentially that you hear about, which consume a lot of electricity. I'm going to come to that in the next slide as well. So this is just on the inference alone. This is before any R&Ds, this is before salaries, this is before rent comes into play. And it's just like a lot of money that they are actually losing on a daily basis, which is like a 100% minus 100% gross margin of inference, and which is like a huge problem. This is an architectural problem. This is not a runway problem. So something has to change every day. Next one. And obviously, the global scenario doesn't have help on this as well. You guys might have seen like recent wars and stuff as well. There were a lot of attacks on like data centers. There were a lot of data center projects that were halted as well. And lately, especially with the rising energy costs, especially after the thing with Iran that is happening, the electricity cost that sort of grows up, like global oil prices obviously rose, and the AI data center draw is around like 1,000 terawatt hours, which just to put into perspective, this is like equal to Germany's annual electricity consumption. This is just for AI data centers alone in the whole world. And 40% of the announced obviously AI projects have been delayed, like by data centers and all of that. Microsoft signed a deal to open a 3-mile island for data centers as well. And obviously, 70% of Americans oppose local data centers, which is higher than nuclear opposition as well. So it is really like a very huge problem that we cannot obviously print more electricity like we could print dollars. So whatever is next can be more concrete, and the people who do get to play, the 5 of them, those five companies are very, very interlinked. So they're all very interlinked when you actually see. So it's like NVIDIA invests into OpenAI, OpenAI then invests into Oracle, and it's like a loop that sort of keeps on happening. Like Microsoft owns 27% of OpenAI, Alphabet and Amazon, they both have invested billions into Anthropic, Meta builds Llama in-house, Oracle plays the infra only. And if you use frontier AI in 2026, you pay one of these five, essentially. So it's like just these five companies that own all of the AI that you essentially use on a day-to-day capacity, which is, if you ask me, it is very scary because moving forwards, the way that we're going, AI is becoming a essential commodity in our day-to-day lives. So it is going to be as essential as, for example, we had calculators back in the day, then we had computers, and we had the internet, and they all we have seen in the past, have all become essential infrastructure that is an essential commodity in our day-to-day lives. And AI is sort of becoming that as well. So a student today in university, like I'm sure most of you guys use ChatGPT for a lot of your homework, at least I used to do that. And then it is just going to become more and more essential in y'all's day-to-day. Like it's going to be in schools. People are going to be using AI in classes. People are going to be using AI in their day-to-day workflows. And it's just going to be becoming more and more integrated in our lives. And that's like the question, that such an essential part of your life, do you only want like five people to have access to that, like five essential companies who are essentially like, it's like a monopoly, right? And only five companies are owning all of your AI, and only those companies, they decide how it actually goes forward. They decide how the model is biased. They decide what goes in. They decide what is right and what is wrong. So the morality is essentially defined by them. Very, very scary place to be in, because throughout the world, like everyone's opinions need to be respected, obviously, and it should not be one company or like five companies essentially, which control whatever AI responds about. So, which is a very scary thing. Again, on to the next one. So right now, if you see the builders, even the people who are essentially building on top of AI, they are consumers. They're not actually participants. They don't own anything in AI. They don't have a say. Like we don't get to have a say in AI and where it's going right now. And we are all essentially consumers, even while we think that, hey, we are building, we are innovating, we are doing something different, we are all trying to make an impact here. But at the end of the day, we are just consumers, and we are, at the end of the day, at the mercy of just these five companies who control all of the AI that we have. So they build the infrastructure, they set the model catalog, they set the prices, and they keep your data, most importantly. Like they train on your data, they use your data to train their models, to make their models better. And then obviously you guys might have seen like OpenAI just recently did a deal with the Pentagon as well, which is like scary if you actually think about it. And they shape the regulation as well. And we, on the other hand, we consume what they ship. We pay the API prices set by them, we accept the terms set by them because there's no other way to actually go about it. We trust them with our data, and we hope the model isn't deprecated. Like there's a lot of people who were sort of bummed about when ChatGPT sort of removed GPT 4.1 as well. As like a lot of people sort of like that model, I don't know why. And we essentially have no seat at the table. It doesn't matter what we say, it doesn't matter what we believe. They control essentially each and everything. Again, privacy, it's a promise. Like we can be like, hey, we can be optimistic about it here that they're not going to use our data, but the news says otherwise. They do definitely train on our data, and they do definitely, when you go into the terms and conditions, it's very explicitly stated that they can use your data. And I think OpenAI recently stated that they can especially use your data in court as well. So it's like a very scary thing if you think about it, because a lot of people share very, very sensitive data with their AI now. It's like a personal companion, right? So like real workflows, you can essentially think about like a doctor reasoning about patient systems, a lawyer summarizing a deposition, and create a prototype strategy. And most providers grant themselves broad rights to read, log, train on your data, and share your prompts, and not just the engineers, like their whole team can essentially see that. So privacy is a promise. It is not an architecture, and people obviously doing serious work, like especially governments and stuff, they cannot just trust like just them saying like trust us and like forever, right? So just let me put all three problems on one screen, and then we can look at that, and then we can see how we can essentially go about it on solving those. All right, so these are the three problems essentially, and there's one question. So the problem number one is obviously like the capex math is broken. There's just a lot of spend being there, being done, and they're just not making enough money. So there's like a cap until that can go on, right? Because it cannot just obviously they cannot keep losing money forever, forever, and forever, right? The second thing is concentration just locks people out. There's five companies that decide what gets built, and everyone else consumes. And the third problem is obviously privacy is a promise. There's nothing actually real that happens to it. Like the prompts pass through unknown hands. You don't know who is sort of processing it. You don't know how your data gets utilized. You don't know whatever is happening on the back end. So these are the three main problems at hand, which is so the main question is so what would a system designed for the opposite look like? What would a system designed to be sustainable? What would a system designed to be inclusive? What would a system designed to be completely private? What would that essentially look like? And the solution is obviously, before we go into the solution, I think this is about time we do a quick quiz just to see what you guys actually listen to. The next one. Okay. Quick quiz. Just to tell you guys like what's at stake here. Whoever answers it correctly, you guys will get a Chutes shirt, right? We have all different sizes, so I hope we can probably cater to. And that's just gonna answer all. So first question is 26 AI capex from the five hyperscalers is closest to C 725 billion. Perfect. That is correct. I guess we can distribute the shares later on, like after the session. Just remember who you guys are. If someone from the AIC team can probably note their names down or something, that'd be great. And then after the session, we can just distribute the shares. All right. Question number two. What share of ChatGPT's 900 million weekly users pay nothing? Sorry? D, right? Yeah, that is correct. Perfect. Just note, just please, like everyone who's in the, like someone from the team, if they can just note those names down, that'd be great. And question number three, the last one of this round, there's going to be three rounds. So AI data center electricity in 2026 will roughly equal the annual consumption of A. No. C. Is you. Yes. Like, I mean, if it was the both of you, you both can get the share. That's fine. You both can get the share. Okay, the correct answer is C, Germany. Yes, that is correct. Just please note your guys' name down. I'm very bad with sort of remembering faces, so for all of the people who are there. Right? Okay, on to the next slide. Let's keep on going. And I'm sorry, the online folks, you guys probably won't be able to participate in this, but that's just about I'm sure it's done already, I guess. All right, so Act One, like the first part of it was the problem, and now we're gonna come on to the response. Like what could be a potential solution? I didn't say obviously that this is the absolute solution for all, but this is one solution that we have thought of, and that is what Chutes is, and that is where we are essentially going. So we have the three forces that were essentially that we realized. One was that there's just too many spend that's happening and not enough revenue that these companies are generating, which is not sustainable at all. The second thing was that obviously only 5 companies decide where AI goes next, and no one has a seat. Like we as people, as consumers, we don't have a say at the table. And third was that there's just like privacy is just a hoax. It's not exactly private at all by any means. So where the world actually goes from here, and we'll take them in order. There's three forces reshaping AI economics, and we're going to take them in order. The first one is obviously um, the inflection point where sort of everything changed. So in January 2025, like most of you guys must remember, a Chinese lab like that nobody had ever heard of. They dropped DeepSeek R1, which is like sort of like the DeepSeek movement, which is very, very popular in AI sort of culture. That is when a model that nobody had ever heard of, a lab that nobody had ever heard of, they dropped a model that matched OpenAI's O1 on reasoning, and which was like 20 to 50x cheaper to serve. And it was trained for like a fraction of what OpenAI's models were trained on, which is like trained for like $5.9 million, which is like on the other hand, like OpenAI, like that, the OpenAI model was like trained for like $100 billion plus. So it's like a technical process, a huge milestone for AI or where it could be and where it could go next. So it proved that anyone can essentially like the frontier capability is not equal to frontier compute. You can essentially create models with frontier capabilities without having that much money. You just have to be efficient enough, right? And then obviously with those open source models, the main thing was that anyone could essentially download them, deploy them, fine tune them, run them. It was not actually closed, right? So you could potentially, if you had the compute yourselves, you could just download them and run it yourself as well. That was like a huge advantage that came in through models like DeepSeek, right? And ever since then, ever since DeepSeek was released, there have just been more and more open source AI labs. Like we have had Kimi, we've had GLM, we have had a lot of these models which compete the top tier models. Like I guess Kimi K2.6, which is like the frontier model by Kimi, Moonshot Kimi right now, that's like almost the same as Opus 4.7, and it did almost like even beats it on some benchmarks as well. So which is like a pretty cool thing if you ask me. Okay, moving forward. So the second thing is the force number two is obviously 90% of future AI spend is inference and not training. So inference and training, they're two different things. Just to tell you guys, so training is essentially when a model is being created, and inference is, for example, the compute that gets utilized when you send a request to the AI, for example. So when you're sending a prompt to ChatGPT, when you're saying hi to it, that's essentially inference when it's actually saying hi back to you. And training is essentially the part where a model is being created. So there are two parts to it, right? And inference is going to be like the major part of how it's going to be. It's like the major aspect of future AI spend, which is going to be inference. So part one is obviously training is just one bill one time and you move on after that. And but inference is it's a bill that comes with every prompt. It's an ongoing thing. So on the next one. So here's the thesis that we don't essentially need $725 billion of new data centers. Like most of the hardware already exists, and this is something that we at Chutes we are working on, especially in model training. So there's just like a lot of hardware that already exists. So the thesis is, and that's what we're also trying to move towards. That's what we're trying to move towards is the hardware that already exists. So there's like gaming GPUs a lot of the gaming GPUs are lying around. We have, or like for example, like NVIDIA GPUs, AMD GPUs. So you can essentially use that in the future to train models as well, which is like going to be like a really futuristic thing because right now there's this AI data centers and whatnot which are utilized to train these models, which is A, very expensive. Two, there's just not enough big GPUs like H100, H200 is like $50,000, $100,000 worth of GPUs is like actually crazy. And that's just for one GPU. And to train such GPUs, we need like thousands and thousands of such GPUs to train like big frontier models that we have. Then we can already use the hardware that all exists, like gaming PCs, crypto miners that are pivoting from proof of work. There's hunting productive use, there's university clusters, there's sovereign clouds, there's small data centers with spare capacity. There's a lot of data centers which have spare capacity not being utilized, so you can essentially utilize them that as well. And there's indie developers with hardware in the garage, and when you add it up, this is sort of comparable to what hyperscalers have in construction, so at their end. So this is just a lot of compute, a lot of sort of idle compute that is lying around, which can be utilized for model training. Like what we see and what we are sort of working towards at Chutes as well is with training, you can essentially train these models even through your phone as well. Like you can essentially provide compute, like you know how Bitcoin mining is. Like everyone can essentially, whoever has GPUs, they can essentially contribute to mine Bitcoin, and then they can make money out of it as well. So that's what we're also actually trying to do in the future. The model is going to be the white paper, and it's going to come out really soon as well, which is essentially any sort of GPUs that you have like around your houses, you can essentially make money out of it as well. So that's just something that's coming really soon as well. Yeah, moving forward. Let's. So now we're gonna finally come to what Chutes is. The first part of it was obviously the problem, just explaining to you guys what the actual problem is. And now we're gonna move on to what Chutes actually is, what Chutes actually does. And now I show you what we built for that word essentially. So coming up, we have what Chutes is. Obviously, we have what Bittensor is. I'm sure. Do we have any people who know what Bittensor is or have ever heard of Bittensor? Bittensor, or it's like a blockchain. Have you guys ever heard of it? If you guys ever heard of it? DAO token, whatever. No? Oh, it's gonna be a fun one. Like you guys would definitely like it. And then obviously we're gonna talk about Chutes, and then afterwards we're gonna talk about what you can essentially build with it, how you can essentially build with it. The people who are participating in the hackathon as well. That would sort of be very beneficial for you guys. Next one. Okay, so there are three keywords here. So this is essentially what Chutes is at a very basic level. It is an open AI compatible API for open source AI models on a decentralized GPU market. What does that mean? It's like, so an open AI compatible API is essentially, what that means is wherever OpenAI can be used, wherever OpenAI models can be used, you can essentially use ChatGPT there. You don't essentially have to change your infrastructure or the way your app is set. You can just essentially change the endpoint, just route it to a different endpoint, route it to the Chutes endpoint, and voila, you're set to, and you're good to go. For open source AI models are again GLM, essentially all of those models, they're like open source models, they come in that category. On a decentralized GPU market. So this is essentially what Bittensor allows us to do. So we have, rather than having a centralized server, we don't own the nodes ourselves. We don't own the GPUs ourselves. What we allow it to do is that we have a cluster of miners. We have a lot of miners on our sort of network. And what they do is like from all around the world, they contribute compute, they idle compute to us. So that's like a lot of data compute. So you don't have to be essentially being like the US, you can essentially be in Russia, you can be in Iran, you can be in Malaysia, you can be in Indonesia, you can be in the Philippines, you can be in India. Okay. So just to give you guys some perspective into where we are at right now, before I go into the other things, Chutes has been around as a project for like around 1.5 years, and our numbers have been like very staggering, especially for the time that we have been in the market. We serve around like 100 billion plus tokens daily, like usually. It lately has come down a bit. Right now, around like 50 billion or 70 billion tokens that we are processing daily, and that's due to the fact that there's like a global GPU shortage right now. So there's just again, that's the problem that we're trying to solve as well. There's just not enough idle compute lying around. So it sort of decreased a bit, but we're still going at a very steady capacity, and we're using this time to make our sort of processes more efficient and going towards profitability as well. Then in terms of users, so this is like a older number. Our current active users on the platform, they're around 700K plus. So we have 700K plus users on our platform. which for context, like just being 1.5 years old, which is like pretty amazing if you ask me. We have had 100K plus users who directly use our API, and then Open Router. Have you guys heard of Open Router team? Anyone use Open Router before? Yeah. So Open Router is like a AI marketplace essentially, which you can get access to AI through it. So we were like a couple months ago one of the top provider in Open Router, and right now we are one of the top providers in Open Router, and we have our most like amount of AI being processed through Open Router requests. So most of that is being utilized here as well. And most people, like obviously, they don't even know they're using Bittensor and or they're using Chutes underneath just because of the Open Router thing. But Open Router routes most of its open source models to us. So just for you guys' information. So yeah, on to the next one. Now we're going to talk about what Bittensor is and how the sort of like the underlying infrastructure is working here, and what how like it's all working underneath. All right, so Shoots is subnet 64. So let me just give you guys what Bittensor is. So Bittensor is a blockchain, just like you guys might have heard of Bitcoin for sure, like Ethereum, Solana, all of that. So Bittensor is a blockchain as well. How that works is the Bittensor is comprised of 128 different subnets. Now each subnet is essentially 128 different companies, 128 different subnets. Each subnet is a company. So Shoots is one of those companies as well. It is subnet number 64, and Shoots is also the biggest subnet on Bittensor in terms of market cap. So how that works is each subnet has sort of three categories of people actually contributing to it. So there are miners, there are validators, and then there are owners who sort of manage like the incentives part of it. So first part is the miner. So in Shoots' context, the miners provide the compute. These are the people who own the GPUs, and these are the people who provide the GPUs. Again, this is completely permissionless. Any one of you guys, if you guys have access to any GPUs, you guys can essentially run those up, and you can start contributing compute onto the network as well and start making essentially earning through that as well. The second part is the validators. These are the people who score the miners on quality, speed, and accuracy and reliability. So these are the people who ensure that the miners, like the models that the miners are running, they're up to speed and they're efficient as well. And then the third part is essentially the owners. These are us. So this is like the main team of the subnet. And we are the people who essentially handle the billing, who essentially handle the UI, who essentially handle the customer support side of things and the tech side of things. So this is essentially how Bittensor works. Again, we have different subnets on Bittensor, a lot of different subnets. Some are contributing to model training, some are a lot of like inference subnets, like just like Shoots, like Shoots is, and that's how it works. And then obviously each of these subnets, what they have is they have their very own token as well. So there's the tower token, and then there is the subnet token as well. So Shoots has its very own token as well, which is like which is called alpha token. So and that's how like the underlying Shoots economy works as well. So for example, if one of you guys decides to become a miner or contributes compute to the Bittensor ecosystem, you guys will be paid then in Shoots as alpha tokens, and then you can essentially sell those alpha tokens for tau, and then you can essentially sell that for USDT or whatever as well. So that's how it works. On to the next one. So that's how it works in the backend. You send a request to our servers, you post it, then our validator essentially score that request. And then we have dozens of independent validators who rate the miners continuously on speed, reliability, capacity, and then it sort of routes your request to the best fit. Then obviously the miner serves your request. The miner are the people who are pushing those GPUs, they're providing the GPUs, and these are the people who sort of host those models. So the miner could be a data center in Singapore, a basement in 100 in Berlin, a cluster in KL, and again, inference runs in a TEE enclave. Now, TEE is a very important keyword here that we're going to be coming on to. And the third part is obviously you get the response back, which is then built as well, and which is like again typically faster because of the decentralization. Yeah, moving forward. So this is how it works. You essentially add, so just to give you guys some perspective on how it all works in the backend. So you add USD or Tau in. Essentially, this is again the same as you would add credits or you would sort of add balance onto your wallet. Um, to use the entrance, obviously. You add in the money, it gets automatically staked into SN64, which is essentially it gets automatically. So this sort of like, for example, you're adding $10 in your account, right? Those $10 are automatically we on the backend we sort of purchase the Chutes alpha token through those $10. Then those $10 or that since it's staking, that comes on to so there are emissions in the Bittensor ecosystem. An emission is basically the money or the tokens that essentially the network adds to like gives to the miners, the validators, or the owners. So there are higher payouts for miners, which essentially miners can earn more tau, and when they earn more tau, there are essentially more miners and the network grows. And when the network grows, obviously there's lower prices because each of the miners they're essentially competing with each other. So there's only limited miner slots available. So the miners are essentially competing with each other on how they can essentially provide more and more efficient compute. So it's again, as I said, it's completely based on merit. It's completely permissionless. Where there's anyone who can sort of contribute compute, but it's also completely based on merit, right? Because there's only a very limited amount of miner slots available. So whoever is the most efficient, they stay on top, and the ones on the bottom, they sort of get deprecated. So where there are more miners, the network grows, and obviously since they're becoming more and more efficient, there are lower prices. When there are lower prices, obviously more users sign up, and when more users sign up, there's more revenue, and when there's more revenue, there's sort of more USD or DAO comes in and automatically gets staked. So it's like an economic flywheel, which um, helps us keep the costs down, which helps us grow our compute, which helps us becoming more and more efficient as well. So that is how it works in the back end. And then obviously there's not financial advice as well, but this is how our sort of like token economics, underlying token economics work as well. So one of the like some of you guys invest in cryptocurrencies or whatnot, this is probably like something that would be of interest to you as well. On to the next one. Okay, so side by side, why it's not this is like the cost structure. I guess we can move on to the next one. Okay. Not really that essential. So these are the models essentially that we have on Chutes, like the main models, like the frontier models that we have on Chutes. You can already see we have Kimmy 2.6, we have the HC model, we have GLM 5.1, we have 0.3.5, we have Minimax 5, M2.1, Gemma, Mistral, and most of these are TEE models. Again, we're going to come to the TEE part really soon, and you can see like the main juicy part of it is these prices. Which is like insanely cheap if you actually put that into perspective with its OpenAI counterparts or like blog counterparts, because those are actually like very much on the expensive and like $20 per like billion output token or something. But yeah, on to the next one. This is how you can essentially get started with Chutes. As I already told you guys, it is OpenAI compatible. So it's essentially you just have to do two lines. You just have to change two lines in your code, and you essentially be using Chutes. So it's like a base URL. You change the base URL, which is essentially our endpoint, and then you just have to essentially add in your API key and the model field obviously. Everything else is obviously all vanilla OpenAI SDK. It supports messages, it supports tool calling, it supports streaming, it supports JSON, or it supports hardware isolated inference, which is the next thing that we'll come on to, which is essentially confidential compute mechanism. TEE is trusted execution environments where all of your requests go in a hardware secure enclave, which is essentially completely private. So next slide. Next slide is again, we're gonna come on to round two of quiz, which is going to be about the second part of the keynote. So just to see how well I have you guys been focusing. Again, same same thing. I'm gonna say the question out loud, and whoever knows the answer, they can raise their hand, and that's how we're essentially gonna roll again as well. So the first question: how many lines of code do you change to migrate from OpenAI to Shoots? Perfect. Correct answer. Okay, very quickly. On to the next one. What share of Shoots LLMs runs inside ATE by default? Now, this is something that I did not say in the presentation, but that was written on the slide. Does anyone know? D. That is correct. Absolutely. So, congratulations. I did not call that out, so that was nice. Okay, third part. A minor on SN64, they cannot read your prompts because B. Yes, that is correct. And just please, guys, again, I'm reiterating the fact that whoever is answering these questions correctly, please just make sure that you remember and you get the shares from me after the session. Okay. And then afterwards, we also have like one last quiz round meeting after this as well. So whoever has not won it yet, you have the chance to do so afterwards. So if you use an OpenAI compatible SDK, you just have to change two lines of code. And the very interesting thing is Shoot sort of comes where you use your AI. Again, we don't essentially believe in making you sign up for new things. So Shoots already works with Cloud Code. Shoots already works with Codex. Shoots already works with Cursor and all of the other providers that are out there. So essentially like Kilo, Open Code, essentially the open source coding agents as well. Shoots already works with those. It's like you just have to run this curl command, and what that essentially does is it is a proxy that sort of loads up, and you can essentially just start using Shoots on these agents as well. So you get the underlying Cloud Code sort of infrastructure and use Shoots in the backend for your inference. And what that allows you to do is it is very low cost. Again, that as I've already stated. So you save a lot of money. And then the second part is it is at the end of the day very private as well. So you don't essentially have to worry about your data being sent to unauthorized people or anyone in the world for that matter. On to the next one. Now, we are going to talk about trusted execution environments, which is like one of the flagship things about Shoots. And this is what sort of makes us different from all of the providers out there. This is essentially a default privacy layer. Like all most of our models have PE on by like normally as well. So how does that essentially work? So we have NVIDIA confidential compute, which sort of encrypts the VRAM. The host OS can be the model weights or prompts. And then as a trust domain, we have Intel TDX, which encrypts the main memory, and this verifies the running software integrity, just making sure that inside the GPU, obviously, there's no memory being lost or whatever. And then we have obviously hardware side and attestation. There's like cryptographic proof you can verify yourself. So by the way, like just to sort of add to this, everything Shoots has or everything Shoots has essentially built, it is all open source. So even the code that Shoots runs on, even the code for our websites, everything is open source. Like you literally just go on to GitHub and you can verify our repository. It is completely open source. Like even our TE attestation, our like each and everything that we run on our network, each and everything that is being run on Shoots, it is completely open source. So even if you want it, you can literally just fork Shoots and make your own version of Shoots. Again, that is exactly what we believe in. We believe in things being open source. We believe in things being accessible to all. So as long as you can contribute, as long as you believe you can even make it better, you're definitely feel free to do that as well. So what this essentially protects against is the miners running your inference. They cannot reach your prompts at all. That was like a problem, right? So for example, you might be thinking that, hey, a person like living thousands of kilometers away from me, they're providing compute to, they're providing the GPUs, right? And as long as my requests are going through their GPUs, they could probably see my request as well. But this is exactly what it protects against, since this is hardware security. Right? The request sort of run through a hardware protected enclave. So the miner running an inference, they literally cannot read your prompts, even though it's their hardware, the host can keep physical access, can extract, read, keys from there. On the next one. And the second part is, so for some people, EEE even might not be enough because with EEE, there's this one thing that that are load balancer at the API edge, they can still probably see your prompts. So because obviously we need that to like sort of route, build, rate image, etc., etc. But even if you're like, hey, I don't want Shoots to see my data at all, like even the people at Shoots, I don't want them to see my data, like the validator, etc. I don't want anyone looking at my data whatsoever. So for that, we sort of build end-to-end encrypted inference, end-to-end encryption, which is essentially um, how it works is the prompts encrypt on your machine and they travel as opaque ciphertext, which decrypt only inside the DEA on the miner GPU. And like to my knowledge personally, nobody else in the inference landscape uses it. And even the people, I think there's one company that essentially uses it, and what they use is our version of end-to-end encryption. So sort of we were the first one who sort of brought this in the market. So how that essentially works, again, you can probably read the technical details. I'm not a very technical person, and this is something that's technical in that sense. So I'm not gonna. If someone is interested in knowing how it works, I can probably send you a link to sort of the article. You can probably learn more about that. But there are two integration paths on how you can essentially set it up. You can set it up through the transport for open SDK. There's literally like 3 lines of setup that happens, and then there's a Docker proxy as well. So any language, it speaks OpenAI chat completions, OpenAI responses, and Anthropic messages as well. So this is like not literally like it's not a because it is like the in a very, very encrypted way. Again, you can probably read the article to know how that happens. But yeah, on to the last part, which is essentially where you can essentially have use shoots and what are the different integrations that we offer. Again, I've already told you guys that we are available on Cloud Code, we are available on OpenAI, like we have an OpenAI Codex proxy as well, we have a Cloud Code proxy as well, and then we work with Cursor, Brew, Kilocode, we work with all of the major AI coding applications or AI coding platforms or AI agents, whatever you want to call them. You can essentially use shoots on OpenClaw as well. So during the OpenClaw signer process, you can essentially see shoots. So OpenClaw already supports shoots on the signer process. You can see shoots as one of the providers, and you can just set that up to that. Shoots also has its very universal AI SDK, so it's like a native provider. You just pick Shoots in your Next.js app as well. And then for the non-technical folks out here, Shoots also has its very own editing nodes as well. So what that essentially means is you can build automation workflows, etc., using Shoots. So you don't essentially have to use like the OpenClaw agent node or whatever. And again, so we have like 14 nodes that are custom built for Shoots. So we have our very own AI agent nodes, image nodes, and whatever. So it's pretty cool if you ask me. And then obviously we have OpenRouter on our platform as well. So again, the main thing here is that Shoot sort of comes to you wherever you're using AI. Shoot sort of comes to you and it already integrates with your workflow that you might already have as well. On to the next one. So we are now coming to the final part of this keynote of this workshop, and we are more than an API. We also have a couple of consumer apps as well. So we have Shoots Chat, which is essentially our version of ChatGPT. We have a lot of like it's a multi-model chat. Like you can essentially select different models for different types. Like for example, there are so since we have open source models and we have a ton of open source models available on our platform. I think it's around 30. So what you can essentially do is, for example, you know that this model works best for this one particular task and this model works best for this particular task. So you can essentially on runtime you can just send one request one model and one request to the other model, since it's multi-model. You can swap between the frontier models mid-conversation, and you can pay as you go from like 0.01, like 1 cent per million input tokens and without a subscription as well. Like Shoots obviously offers subscription as well. We have 2 tiers of subscriptions. We have a $10 plus tier and a $20 pro tier. But you can essentially just run it through pay-as-you-go as well. Then we have Shoots Share. So how many of you guys have used ever Perplexity before? Ever heard of Perplexity or used Perplexity? Right. Shoots is essentially our version of Perplexity. It's AI-powered search. And we have an open source code base as well. Pictio, it is our role-playing platform, so you can essentially create your own characters through that. So that runs on Shoots platform as well. Now, sign in with Shoots. This is a very like one of the best things in Shoots, in my opinion. So what that essentially does is sign in with Shoots is two things. So it is OAuth for AI apps. Like for example, you might have heard about Google OAuth as well. So it's just OAuth for AI apps. User can sign in into your app with their Shoots account, and the big part of it is they can just authorize you to use their credits. You set the AI features, they pay the instance with. So what that essentially means is, for example, you have created an app, but being developers or being founders, you essentially have to pay the inference bill yourselves, which is sometimes with the developers that we have talked to, that is sometimes like a huge hassle because especially if you don't have to raise any money, right? You essentially have to pay the inference bills on your end, which becomes very taxing, especially if you sort of have unprecedented growth like you initially might have just been like, hey, I'm just gonna send this out to my family, my friends, and then eventually news gets out and you essentially have like 100 users overnight. And what that does is then your inference bill is like through the roof. So this is what it protects against. You just literally build an app, you use sign in with Shoots, we handle the OAuth, and whenever the user signs up, they are prompted to create a Shoots account. They're prompted to just add credits on their Shoots account, and then they just use their Shoots inference to use your app. So it's like a very easy process to sort of monetize your app as well. You monetize the part that you are adding value, and like the back end part of it, like the inference side of things, like Shoots handles on its own. On to the slide. Okay, this is the price cap part of things. You can essentially see like floor opens 4.6. It's like 5 million, $5 per cost and $25 per million output cost. And GB 5.5 is essentially like pretty much the same as well, even more expensive. And this is like in comparison. So Kimi K2.6 is like 7x cheaper. B3.2 is like 59x cheaper. Minimax 2.5 is like 21x cheaper. And Mr. Nemo, which is like a basic model, it's not one of the frontier models, but that's like 250x cheaper. So just to put that in perspective, like the cost savings here, they are pretty hefty in that sense. But yeah, on to the next one. So this is essentially what you can ship. So some of you have ideas, some don't. I'm going to give you some directions that you can probably use for, especially this is especially for the people who are going to be participating in the hackathon as well. So the first is obviously like the direction I'm going to be giving you is obviously clear towards strengths, and then the second part is tied directly to the AI management price categories. And we have a signing with Shoots special track as well. So the best implementation of signing with Shoots, there's like a separate price for that. So on to next slide. What you can essentially build using Shoots. So again, Shoots, you can essentially build anything and everything using Shoots, whatever you want to do. But in terms of what we are essentially looking for, you can create something because see, the main sort of like the USPs of Shoots is that it's low cost and it is completely private and it's open source. So just to say to the strengths, you can essentially create a TEE only apps, a workflow where prompts must stay private. It could be like some sorts of legal implications, medical implications, internal laws, that record to the TEE models, or even you can add an end-to-end proxy. You can even create like a end-to-end encrypted app, end-to-end encrypted like chat app or something, which could be really cool. You can also create like agentic workflow. So they Shoots works with OpenClaw, Shoots works with Hermes as well. So you can essentially create a open source like agentic workflow where they are because long running agents are obviously too expensive on closed APIs, and you can build one with using the Chutes model, which is going to be like really cheap. And this is a talk that we're going to do as well. So I think that's tomorrow. So one of our devs is actually going to be talking about how you can essentially use tools to create self-orchestrating agents, use tools to sort of make your processes easier, use tools in your day-to-day processes. Because this is something that really cool. So within our internal processes as well, we just set up an agent recently, which is called Rain. And what that does is it has sort of automated and which has sort of took over like most of our day-to-day operations that we're doing, especially in marketing side of things. So that's like a really cool implementation that we have done, and we're gonna show it to you guys tomorrow. It's gonna be a hands-on workshop on how you can essentially do the same for you. So building like AI agentic assistants and how you can essentially use Qt and these agentic workflows to your advantage. That's going to be a really cool session. Like I would definitely recommend you guys to join in. We are obviously looking for sign-in issues, like apps that are using sign-in issues. So just ship any AI product without funding the inference yourself. Users authenticate and you call it credits. So obviously best use of sign-in issues will win the prize as well. You can create some apps related to like multilingual SEA Southeast Asian content as well. You can create something as a mobile app because Shoots doesn't really have any mobile apps. So if you essentially create those, that'd be really cool as well. You can create like an open source AI tutor for students as well. That's just a cool application that could work out as well. And like obviously like the main thing here is you guys can think for yourselves, just think what ideas that you really care about, and then just see where you can add Shoots in. Main thing is obviously just play to your strengths, play to what Shoots stands for, which is essentially privacy and being open source. So yeah, that's pretty much it. On to the next one. Okay, we have the last push down now, and after that we're just gonna end, and we're then gonna have like a quick Q&A session as well. So any questions that you might have on how you can essentially use Shoots, how you can essentially get started with Bittensor, if you are interested potentially on that. So this is the last one now. I would like everyone's attention here. If you want to share, it's obviously if you don't want to share, then you it's fine as well. But question number one, okay. So for example, there's an app for doctors summarizing patient notes. So what is the best Shoots feature to lean on in this scenario? C, end-to-end proxy. Yes, that is correct. Perfect. Question number two. Your hackathon team has zero budget for inference. What is the best move for in this case? C, that is Simon Shoots, which is correct. Question number three. Why can't Shoots sustain prices that would bankrupt OpenAI? C, perfect. Yep, that is correct. We have just a different cost structure. We have no GPU capex, and miners are paid in Shoots is that for Bittensor. Already enough, like all of these were C, which is a good thing. I did not think about that. But anyways, congratulations to all of you guys. Make sure that you remember whoever answered, and we're gonna hand out the shares to you guys later on. Um, Next slide. So this is how you can essentially get started. You can just head to Chutes.ai/app, sign up, grab an API key, get started with it. You can essentially head to our docs as well, where we have all of our implementations and developer docs there. For anyone who's interested, you can just head to docs.Chutes.ai. We have the API references, model catalog, registration guide, and end-to-end encryption setup there as well. You can essentially head to our GitHub as well. It is completely open source. You can see our how we have essentially set everything up. I would definitely recommend like all of you guys who are AI majors, definitely check it out. Whoever is interested in these sort of things, it's going to be a really cool learning experience for you all as well. And then obviously the teams here, you can essentially go to the AI marathon website as well, or go to the Shoots booth for if you have any questions. Next slide. So this is the thing that I sort of want you guys to take home. Why it matters here. So just build something. Mind, main thing here is just care where the AI market is moving forward. Because again, the thing that I've already told you guys is AI in the hands of 5 companies, and this is something that we as Shoots we really care deeply about as well. Like, sure, Shoots is a for-profit, but trust me when I say it, we and the team and the Shoots team we really care about AI being accessible to all and AI being secure. So that's just something we really care about, and I think you all should care about that as well. Like just making sure that you are implementing best practices when you're using AI. Obviously, being ethical is one, and second is obviously caring about your data privacy. Like your AI obviously knows like quite a lot more about you than you might actually think it does. So yeah, that is pretty much it. I'd like to thank the obviously like the APU AIC team for organizing this. There's still a couple of days left. We also have a workshop tomorrow as well. Make sure to join in if you're interested, and that's going to be really cool for like technical folks as well, because that is going to be very interesting. We're going to talk about self-orchestrating agents and whatnot, like open armies, and then all of the different agentic workflows that exist out there. And yeah, now I guess it's gonna be the floor. I'll open the floor for you guys for any questions. Any good questions, you guys will get the shirt for well. We'll get you guys to ask questions. Anyone. The online folks can ask questions as well. We can take any of those about shoes, how you can essentially use shoes, about Bittensor, you guys have anything in your mind. No questions? You have any questions online? Oh, okay, cool. Then thank you so much for joining. I hope you guys use Shoots. I hope you guys try it out. And yeah, thank you all for joining. I wish you guys the very best of luck, and I hope you guys have a nice day. Thank you so much.